Write back strategy is a high performance caching strategy. When the number of writes are significantly higher than the number of reads, it helps to improve performance. The data is first returned to the cache and then to the database, so there can be some lag between them, and hence it's an eventual consistency and not a strong consistency. It is suitable for non-critical data like YouTube views, Twitter likes, etc. When there is new data, it will be written directly to the cache and then to the message queues in a synchronous manner. From message queue, it will be returned to the actual database in an asynchronous manner. We can use either message queue or brokers like SQS or Kafka. Let's say after writing the data to the cache, there are some failures while trying to write to the message queue or broker. How we can address them? One option is to use exponential backoff with retry. Worst case, we also call to the DB in the same API call. It will be slow, however, it will ensure that the data is returned to the actual DB. Then there is a transactional outbox pattern where we write the record to a local DB, and there is a background worker running which will fetch from this local DB and then push to SQS or Kafka. We also need to ensure that in case while saving into this local DB there are failure, we either roll back the cache or you first try to save to this local DB, and if it is successful only then try to save it into cache. Also, it is since it is much more better to have a single process, there is also an option of write ahead log. Since it has a separate recovery process, it is faster than outbox pattern, but it is lesser reliable. You also need to accept the risk that it is more suitable for non-critical applications. So if there are any failures, you basically just log the error and have alerting set up on top of it so that you can capture and retry those. What if your message queue fails itself while sending the data to the database? You try to capture those using dead letter queue. Read flow is very simple and similar to cache aside pattern, where you capture the data from cache. If it is not present, you fetch from the DB and store it into the cache. Since the data is directly returned to the cache, it has a higher write performance and it supports high concurrency. We can also batch the data in from the message queue or brokers so that it has reduced load while writing to the main DB. Disadvantages include risk of data loss, and since we have to handle so many failure scenarios, there is a complication in the implementations as well. It is best for high writes and non-critical data application.